Welcome to the first of the Chapter 4 podcast. This Chapter 4 is about linear motion, and we're going to be talking about motions in terms of position, speed, direction, and acceleration. Our first section is called Motion is Relative, and the main point about this section is an object is moving if its position relative to a fixed point is changing. And we often think things that are at rest, but often they're actually moving. For instance, right now we're all moving on this Earth. The Earth is rotating around the sun. It's also spinning on its axis, and on top of that, the sun itself is moving within the galaxy, Milky Way, called the Milky Way, and the Milky Way itself is even moving. So what we need to talk about is when we talk about motion is what one object is doing with respect to another. So we say the object is moving relative to some other object. So a book at rest on a table is actually moving 30 kilometers per second relative to the sun. So if you talk about the book, once again talking about our galaxy, remember our galaxy is moving, so the book even moves faster if you're talking about it relative to the center of our galaxy. Now this gentleman right here looks like probably a teacher chaperoning a bus trip, and he's walking probably on a moving bus, and so maybe on the bus he's actually maybe he's not walking, maybe just standing there. So relative to the bus he's not moving, but relative to people outside he is moving because he's on the bus. So your motion is relative to whatever your frame of reference is. If we look at these cars here, they're moving relative to the track. So once again, discussing motion, we describe it moving relative to something else. So if you look at the space shuttle here, and this is space shuttle program has just ended, the space shuttle moves at 8 kilometers per second relative to the Earth. Take a moment for a second. 8 kilometers in 1 second. That is nearly 5 miles in a second. Racing car, the Indy 500, reaches speeds of 300 kilometers per hour relative to the track. And so most of these things that we're talking about, this is very important, most motion that we talk about is measured relative to the surface of the Earth. Both these examples, the space shuttle and the Indy car, are both talking about motion relative to the Earth. Let's talk about being relative to the sun. Well, the Earth is moving 100,000 kilometers per hour relative to the sun. So if we think in terms of our relationship to the sun, we're moving 100,000 kilometers per hour relative to the sun. So let's think. A hungry mosquito sees you resting in a hammock in a 3 meters per second breeze. How fast and what direction should the mosquito fly in order to hover over you for lunch? Well, he's going to need to fly toward you into the breeze, because otherwise he is in air that is actually moving at 3 meters per second. So he actually has to move 3 meters per second in the opposite direction just to stay above you. So here's a concept check. How can you tell if an object is moving? An object is moving if its position relative to a fixed point is changing, and you have to say what that other object is, what that fixed point is.